Same challenge. Second part, concerned with the initial sanitization of the requests and preparing some tools to compose valid requests from the CLI, very similar to what the web interface is doing. So when you go on the website, you go to this data download form, so something resembling that very closely from the CLI. And then there is another part that we address, but it's not yet complete, I guess, the automating of smart resubmission. So in case you are interested into data that is released, let's say on a daily basis, you just automatize as much as you can this process. Oh, nice to meet you in person.
Thanks, Petrus.
All the best. A short introduction on the team. Tom and Irina from Portugal, both software professionals.
Thank you. Yes, and we definitely felt at a more personal level the benefits of the center's atmospheric data, because in northern Portugal where we live, there's active fires at the moment, and so we were monitoring the air quality on a regular basis to decide whether to open the windows or keep them closed. And so we felt like the flight here was a bit of an emergency rescue. So, yeah, that was a very interesting presentation from the previous team. And I did a quick queuing theory calculation based on an extrapolation based on some data a few months ago from the system. And it looks like at any given time, there can be 2,500 requests waiting for data requests, while 300 to 400 can be running at the time, leading to something like 100 requests per minute, maybe peak or average capacity. And each of those requests need to wait on average about 26 minutes. So there's significant amounts of time for waiting, for processing, and data involved. So any efficiency improvements there can definitely reduce the time for users, as well as the burden on ECMWF systems. So Irina and I worked together to achieve several deliverables related to handling dataset requests to the system. And we definitely want to thank Petrus and Janata and Angel for their help. So the main deliverables, as you might remember from the midterm report, were a validation capability. So since the requests are ultimately made through Python calls, we provide a Python library to do some validation. And I'll get into more details about that in later slides. Additionally, since the last presentation, we added a check for new data availability. So whatever the request was in the past, we can look at the latest data extent pulled from the API, and then show what the next available date range would be for pulling data. And finally, something that took a lot of work in the last month or so was building a terminal-based, what I would call a request management system, where users, much like in the web interface, can go through a terminal-based application on their own computers to which also uses the API as well, just not a web interface, to create requests and also save them and resubmit them and more. Our work is in this repo, which I think will be made public soon. And this is just a refresher of what the web interface looks like. You might be familiar with this. There's a series of forms to define values for dimensions that you're interested in. And then that request is translated into Python code that can be run through a CDSAPI Python library, which already has existed for a while. And we also use that. I won't go over this too much. The other team covered the constraints. I'll just mention that there is also a form schema that defines what values are available for each dimension, and also has some additional details about UI concerns. And this is what the web interface relies on, and we also rely on this. So just going through the library functionality that we add, which is complementary to the CDSAPI package. Here's a request in Python. And we we have a top-level API module called API, and so on that module there's a function called validate request, which wraps up all the validation capabilities that we offer in separate functions into one function, and summarizes whether the request was deemed valid or not. And when it's not valid, it shows details about why and where it's specifically not valid. And so we hope that will definitely help users do self-service and catch these problems, as well as help ECMWF support staff figure out what went wrong. An initial version of the validator, assuming strictly that only what was available in the form definitions for those widgets would be allowed. If you look at historical requests, I think 50% of the historical requests would have been invalidated. And the reason is there are a lot of exceptionals, behaviors and things that are allowed by the actual CDS engine that a strict interpretation by the form schema would actually disallow. So we incorporated a lot of those special cases, the ones that made sense. So it's still a relatively flexible validator, but built on a strict foundation. So the new function that we added in the last month or two was checking whether the request has new data in the next time window. That is, the time window beginning the day after the previous request ended, up to the latest temporal extent defined in the API for that data set, and if any exists. And so hopefully this would allow users to not resubmit a request and also use differential requests. And to that end, we have an early version of a function here that can modify the previous request to change its date range to use that next time window function. And then a user could resubmit a request for that next time window, which would be a much smaller request than their original one, rather than trying to do a combined range. Okay, so next I want to go over some of the new functionality in the terminal app called Request Composer. So this tool, the idea is to allow users to create valid requests in their terminal UI rather than the web browser. I'm not sure how much adoption this will have, but it was definitely fun to make. So they can define values for each of the dimensions, walking through step by step. And at each decision point for each dimension, values will be, due to the constraints, those will be applied, and some values will be disabled, just as in the web interface, some values are disabled due to your previous selections and the values of the constraints. Then after the user creates that request, it can be submitted to the CDS service, as well as saved locally to a database, which allows many possible things. So this will be a very basic interface. It is a terminal app after all. The first step is just to get the user's permission to show them where the database will be stored. It's a SQLite database, which is just a single file. And so after that, good, the animations work. These are GIFs. So each screen has a single purpose, each view. And this one is the main menu, which allows them to create a new request, or as we'll see later, look at previous requests. The next one allows the user to select the data catalog. So there are several data catalogs, ADS and CDS being some of the main ones, and I think there are a few additional ones that could be added over time. I should say that this app is based on a Python library called Textual. If you look up Textual or Textualize, you'll find that. Yes, okay, so this flow shows the possibility of selecting the catalog, and at that point you can also paste in a request, one of those Python requests, and run the validator. So you don't have to enter any Python yourself, you just paste something in and you can check the validity of the request. Otherwise, you can continue with the flow where you select the data set and go through the process of selecting each dimension, as you'll see here, to go through the flow of creating a full request. And we'll just kind of let this complete. I'll add that there are a few specialized widgets that are not supported yet. The area widget had a small problem, so we just disabled that for the time being. Okay, this should almost be complete. Okay, here you can submit the request, and you'll see a little bit of, oh, it doesn't show it. At that point, you would see a little bit of logging from the CDSAPI Python library as it submits the request. So it's a little bit of a progress indicator on your screen there. It might show that here, actually. Okay, it was very brief. Okay, there it is. And just as you can currently with the web interface, you'll see that requests that are submitted through this tool will be visible in the web interface. You can check the status, whether it's in progress or not, and then download it as well on completion. Since these requests are stored to the local database, you can, in our interface here, look at saved requests, and then there's keyboard commands that allow you to go to another view for a specific request to drill down into previous attempts to submit that request with some various data that you can scroll through here in this table to see if there are any submission errors or if it was successful. One limitation is it doesn't automatically refresh itself. That is possible through the textual API. It's just, it would take a little bit more work to implement that. So you might have to check back in a few minutes to see the status. There is the capability to resubmit a request, as I mentioned before, using some of those API functions that we added. The recalculation of the next time window and modification of a previous request is a little problematic because the dimensions for each data set can vary in how they specify time and date. And so having a comprehensive solution there would just take a little bit more extension. We cover some of the main year, month, day patterns that we saw in many of the data sets. Okay, so I mentioned a few of the limitations already. Some of the other issues you might see when using the request composer are if you haven't already accepted the license for a data set, you will see an error in the submission errors view, and you would have to probably go online and accept that in order to successfully submit a request. There are some other errors that are possible that can be visible there. Sometimes the remote download form is not available from the remote system, so you have to wait. And there's a little bit of a problem with the downloads. The async Python context that we're executing within might be involved in that. One of the libraries, there's an issue when using CDSAPI library to download, but it still has about a 67% success rate there, and you can always download it from the website. Yes, one other limitation is that the ADS catalog, some of the widgets needed for that require user inputs that have not been implemented yet. So there's a little bit of extension work to do there to more fully support the ADS datasets. But the good thing is that about 84% of the CDS datasets are fully supported, and that's, I think, roughly 90 or 100 datasets. Okay, so some future work would be to refactor some of the validation code. We kind of implemented that, especially for the special cases, on a little bit of an ad hoc basis. And at the end, it became more apparent that it would be useful to express the special cases as Boolean true-false facts that then could be used in the appropriate places in combination with each other to decide whether or not to apply a special case. That would have resulted in some cleaner code. And so there's an example started, but it's not fully refactored in the code base. So that would be one thing to follow up on. And it's also possible for the validations to cover more of the special cases that the CDS engine supports beyond the strict validation case. So for the request composer app, let's see. Yes, you can paste a request to run the validation, but it doesn't actually save that request and allow you to submit it like you can when you click through and select all the dimensions. So that might be a nice feature to have. And let's see, I mentioned a few of these already. Okay, we did attempt to include error modals. So in many websites, to get a status, sometimes a modal will pop up like a little window that you can then dismiss after it gives you the information. The library that we use, the textual library, we implemented this, but there was a little problem getting it to fully work without interfering with the rest of the views, and so we kind of disabled that for now. But there's code in place, and that could be, corrected at a later time. And yes, and I mentioned also updating the views when new data arrives. That would probably be a nice feature to have. So in the end, our code base performs uniform exception handling and also conditional return results for success failure patterns. And so this was nice to be able to bubble up problems to the top for API calls or also for use within the app. One of the advantages, despite some of the work in progress and some remaining work to be done in the request composer, is a lot of the basic problems of the app were solved. We ran into a lot of issues with how things looked in the textual documentation versus how they worked in practice or interfered with each other, and we found some workarounds for that. And so that should save future maintainers some time so that they can just mainly focus on extending the basic functionality in very localized places within the code base. And there are some technical patterns also that will save some time and be conveniences for programmers. And I think this is the last slide. So in the end, this library provides value that could be incorporated into the CDS internal systems to screen requests at the beginning and give early feedback so that requests don't enter the system and have to wait until the end to know whether they were invalid or not. There is some of that logic already in place, but this might improve that logic. We expect this will reduce the number of issues reported by users and the time spent by ECMWF staff. And otherwise, without something like this, there is not a good way to have quick insight into the precise nature of request failures and how to fix them. And so this provides a solution for that. And also, with the other team's work, it would be definitely a great idea, like they said, to integrate this, to take the initial request and then split it into many requests that then could be saved to the local database, and these requests could then be managed over time. So I want to thank Irina, my co-partner on this, and we spent a lot of time together working on this project and doing lots of QA, and it was very fun. So thank you again.